Hello students, this video is concerned for class 12 and the chapter is surface chemistry. Now we are going to start with the topic Phenolic adsorption isotherm. Now in 1909, Phenolic he gave a relationship and that relationship was x upon m is equal to k p raised to the power 1 upon n. Now the value of n will be greater than 1. That will be the value of n will be greater than 1. Now x is the amount of gas adsorbed, and the gas will be absorbed on adsorbent. So the amount of gas adsorbed on mass m of adsorbent. Now the K and N both are constant and they depend upon nature of adsorbent and gas at a particular temperature. Now the left is P, the P is pressure. So this is a relation and these are all the terms which are involved in the relationship. Now we are going to plot a graph between x raised to m, x upon m versus P, that is pressure. And you can see there are three curves and three curves are at different temperature. And the first curve is at about 195 Kelvin temperature. Second is this one, the lower one, 244 Kelvin, and the lowest one is 273 Kelvin. Now we can see the line. This line show that at a fixed pressure we are talking. So we can see that as the temperature is increasing, the curves are going in a lower direction. See, this is a 195, which is the lowest temperature among three. You can see at lower temperature the curve is at that much height, and at 273 Kelvin, which is the highest among three, it is at this much height, at a lower height. So by seeing this graph we can say that at a fixed pressure the physical adsorption it decreases with increase of temperature. So this we can say with the help of a graph. Now one more graph for the same relation, x upon m versus P, that is pressure. Now I am going to write again the relationship x upon m equal to 1 pressure raised to the power 1 upon n. Now the 1 upon n, the value of 1 upon n will be between 0 and 1. Now this area is shown at the low value of pressure. Now this area will show at the high value of pressure, and this one will be at the moderate value of pressure. Now the equation will change according to the pressure. That means at low value of pressure, at high value of pressure, and at moderate value of pressure. Now at high, we will be going to start with the low value of pressure. The equation becomes x upon m equal k p. Now the power is 1 upon n and the value of 1 upon n is 1. The equation becomes x upon m equal K multiply P. This is the equation at low value of pressure. Now at moderate pressure, x upon m will be equal to K P raised to the power 1 upon n. For the high value of pressure, the equation becomes x upon m equal K P, and the 1 upon n value at this time will be equal to 0. So the equation becomes x upon m will be equal to just K. So at high value of K, at high value of P, not K, P, x upon m does not depend upon pressure. But at low value of pressure, x upon m that depend upon pressure value. Now this was a graph regarding this equation, and at high, at low, at moderate and high value of pressure. Now you can see a dotted line. This line denote PS. This is saturation pressure. Now at value of PS, that is saturation pressure of equilibrium pressure, now you can see at this point x upon m have reached its maximum, and after this no change in x upon m value. You can see there is no change. So you can say x upon m value after this point has almost become constant. Now this is the saturation state, and this is known as the saturation pressure. Now again I am going to write the same relationship. On both the sides you will take log. It becomes log x upon m will be equal to, now the both have a multiply sign in between them, so it becomes log a plus log b. The log a will be k, the power of this, the b portion will come here, and this which is b. So log, we are saying that when we multiply log a multiply b, so we get a formula log a plus log b. Now here a and b is k raised to the power k p. The p is raised to the power 1 upon n. Now when we take log on both the sides, so it will split like log. Now a will be k, so you will be writing like this. The power comes here, and now b is p, so we are going to write like this. So this is how we got this equation. Now we are going to plot a graph between log x upon m versus log p. Log p. Now you can see a straight line. Now when we are plotting a graph between two terms, now the left term with this thing, because we are plotting the graph between two, so the left thing with this term, that is 1 upon n. Now 1 upon n will give the value of slope, and the left will be the intercept, will give the value of intercept. The graph between both of them is a straight line. When you plot a graph between both of them, we get a straight line, and the slope value will be 1 upon n, and the intercept value will be log k. Now the straight line will show the validity of phenolic isotherm. This straight line will give the validity. Now, there is one point about phenolic adsorption isotherm that it fails at high pressure. This was the last thing about the Freundlich adsorption isotherm. Now after this, the next topic becomes adsorption from solution phase. Now, solids can adsorb solutes from solution, and you know that solution is made up of two components. One is solute and second one is solvent. Now, to prove this statement, I'm going to take an example. Example is, I'm going to take a solution of acetic acid in water. That means we have prepared a solution and it is shaken with charcoal. Now, after some time you will see that the concentration of acid, it decreases. That means someone has adsorbed acetic acid, that is why the concentration is decreasing. So here charcoal is the one that adsorbs acetic acid, that is why its concentration decreases in the solution. Now for this portion also, there is an equation which is x upon m will be equal to k c 1 upon n. Now this is also given by Phenolic equation. This equation comes from this side. Now previously we have seen here was pressure. Now it is C. Now C is equilibrium concentration. Now taking log on both the sides, we get log x upon m, that is equal to log k, and the power will be written here, and log c. This is the equation. Again we are going to plot a graph between log x upon m and log c. Now this will give me the value of slope. This similarly which we have previously done, and remaining portion, this will give the value of intercept. Log k. Now again the straight line will prove the validity of Phenolic equation. Okay. Now after that, now comes the extent of adsorption. Now first of all, the extent of adsorption, it decrease with increase of temperature. Whenever temperature will going to rise, the extent of adsorption will decrease. Second, the extent of adsorption will increase with the surface area of adsorbent. Third point, now it also depends upon the concentration of solute in solution. And the last point, it also depends upon the nature of adsorbent and adsorbate. That's all for this video. If you like the video, then like it and subscribe my channel. Thank you.